Welcome to Study Loop.
In part A, we want to convert 1900 revolutions per minute into radians per second. So 1 revolution is equal to 1 full rotation around the circle, which is equal to 2 pi radians. So this is exactly the same as unit conversion, where we have our 1900 revolution per minute, and I will multiply this by 2 pi radians divided by 1 revolution. So here you'll see that my revolutions gets divided out. Now I'm left with radians instead. So do the same for minutes. So here, multiply that by 1 minute divided by 60 seconds. And here my minutes gets canceled out. And I'm left with some value in terms of radians per second. So if you plug this into your calculator, you'll get a value around 198.968 radians per second, but since we have 2 significant figures for 1900 revolutions per minute, this is approximately equal to 200 radians per second. So that is our answer for part A. Okay, so for part B, we want to know how many seconds will it take for our propeller to rotate 35 degrees. So we are given the angular velocity in this problem, and from part A, we've already converted our angular velocity in terms of radians per second. So I will be using that value. So our angular velocity. So this is just from part A, so 198.968 radians per second. And I will be careful about not using our rounded answer, because you don't want to round up the final answer too much. You want to consider the significant figures at the end. So let's see. So now we have our 35 degrees that we want our propeller to rotate, but given that our rate is in radians instead of degrees, we should convert our degrees into radians. So we will multiply this by pi radians, divide that by 180 degrees. So degrees is not a unit, but if it helps visually, you could sort of see that the degrees will, I guess, be canceled out, and you're left with some value in terms of radians. So now we will actually use our angular velocity in order to find out how long will our propeller take in order to rotate 35 degrees. So I will multiply not by the angular velocity, but by its inverse. So every 1 second, our propeller will rotate around this value. And if it helps again, my radians cancels out, and I'm left with some value in terms of seconds. So if I plug this into my calculator, I will get approximately this value here, 10 to the negative 3 seconds. And considering that we were given only 2 significant figures, our answer will be this.